Check, check. Okay, mic's working. Good afternoon, everyone. Wow, this room is kind of sort of spread out pretty wide in this direction. It's like more people are on this side of the room than this side. Okay, so we can get started. This is one of my favorite times to do a presentation. Like, almost 90% of my talks are right after lunch, and always I'm greeted by this very enthusiastic audience who's had a pretty favorable lunch today, and I'm sure the desserts are really awesome. Everybody has had coffee for sure. All right, so we are today going to be talking about how to build high-performance apps using Microsoft Azure Redis Cache. My name is Pranav Rastogi. This is my Twitter handle, and this is the talk title, M350. So just making sure that you are in for the sort of right talk. Now, this talk is a 300-level talk, and I'm going to be sort of covering at a very high level what is Redis, and what are we doing with Redis in Azure? What feature sets do we offer? How do you use Redis in your applications? And then towards the end of my talk, I'm going to be covering more, you can call sort of like best practices. I call it FAQs, gotchas. And these are lessons that we've learned from our service. Like, we've been running this service for the last 1.5 years at GA in September of 2014. And we have collected lots of logs. We have a lot of analytic data that shows some of the common usage patterns. I'm highlighting the ones that people stumble upon quite often, with the idea that sort of you can take these learnings and be productive with the Azure offering. So before I start, how many folks have used Redis? Okay, so there's roughly about 10% of people. So it's good that I'll introduce Redis to you. And have you used the Azure Redis offering? Okay, so like about 5 people. That's perfect. So I think the talk is going to be fairly at a 300 level talk. Like, I'm not going to go deep dive into architecture of how Redis was built, and because I don't think that's what we are here for. We are sort of here on how do we use Redis effectively in our apps. If you have any questions that you want to ask, just raise your hand and shout out. I'll just stop and answer questions. My goal is sort of with this talk is for you guys to understand Redis and at least be able to start using Redis right after my talk. So this is a little bit of introduction about myself. I'm a program manager for the ASP.NET and Azure team. So I partly work on ASP.NET as well. Like, I had a talk yesterday on like sort of introduction to ASP.NET 5, where I covered what's the next generation of ASP.NET that's coming around. I also work on Redis Cache, and that's why I'm over here. I've also sort of co-authored this book on ASP.NET. And this is a picture of me sort of hiking up Mount Adams in Seattle. And the reason I have this picture is, like, I took a picture and uploaded it to Google. It was not snowing, but Google decided that, hey, it's snow, so it has to be snowing. And so it sprinkled all this snowflakes, and I sort of love this picture. I was fascinated when Google did that. Anyhow, so this is a little bit of introduction about me. I'm sort of looking forward to my time after the conference, sort of go around in New Zealand as well, and sort of maybe hike a little bit. If you have any recommendations, I'm all up. So this is the agenda that I talked to you about. Like, what is a common caching pattern that we use in our apps? Like, what is Redis? And I think a key message over here is going to be around where Redis is more than a caching solution. And so how do you leverage these features of Redis, which make it more appealing than just being a cache engine? What does Azure offer? And then at the end, we look at sort of these FAQs and best practices. So in a typical caching pattern, like, the reason you want to introduce a caching layer is you have a web front end, which is talking to some backend storage. And storage in this case is any persistent store. That could be SQL, MongoDB, DocumentDB. I mean, you name it, just a persistent store over here. And you would generally sort of make a call to SQL and get that data. And then you would display the data in your web tier. The problem with sort of doing this approach is like each time you make a call to SQL, like SQL queries are expensive, they take a lot of time, and the more time they take, the more your users have to wait in your site to sort of get the response back. So you don't get a very smooth experience by just relying on fetching data from SQL all the time. And so most times what folks start introducing is this concept of a caching layer, which sits between a web front end and a back end. And the goal for the caching front end is sort of to have cached commonly used data for that application. So if you are building an application like Twitter, let's say you want to display the last 5 tweets or the top 10 tweets, you want to cache that data closer to the user so that the user can access it easily. But each time a user tweets, you want to go and store the result in the database and then cache it later on and stuff. So that's just a basic 101 on where does a caching layer in general, like nothing specific to Redis, sort of fit into the picture. And sort of where Redis starts to add benefit as compared to sort of any other caching solution is it guarantees, for the most part, a very high throughput. And so Redis is like super fast in processing lots of data. So you can talk about thousands of ops per second is what we're talking about. So if you're building very high throughput applications, Redis is perfectly suited for that scenario. It also provides you with this low consistent latency, and the keywords are sort of low and consistent. That means that for the majority of your workload, you should see that you can complete your results in under 10 milliseconds. And so, which is pretty fast. And if you just straight up compare this response time of Redis versus SQL, like it's super fast. So that's sort of the key benefit that Redis has as an industry standard. And this is nothing specific to Azure. Like this is the generic Redis feature that exists. And in a grand scheme of things in Azure, sort of all of this makes sense if your web front end and your cache front end are sitting in the same region. And the reason you want to have that is because from the web front end, you're making a network call to your caching layer. And if your web and your cache layer are in different regions, then you'll pay the price for the network latencies between the two regions. And then your response time is then going to go up. Your app's going to become slower. So as a best practice, you want to keep all of them in the same region itself. So let's quickly see a demo of this 101 caching layer. And let me stop extending and duplicate my screen. Right. So what I have in this application is, this is a simple ASP.NET application. It's talking to a backend table storage, and I have about 1 million records stored in that table storage. I also have the indexes of that data cached in my Redis cache layer. And so I'm just going to query on my customers table based on a customer name. So in this case, I'm just going to put some random name. And then I'm going to say search. And what's happening behind the scenes is on the left table is the time it took for me to query this data from the cache. On the right table is the time it took for me to query this table from table storage. So the order of difference is between 20 milliseconds to about 2,000 milliseconds. So it's a factor of 100, basically. So that's the raw benefit of just having a caching layer is your response time increase drastically. And I cannot emphasize this fact of why do you want to have a caching layer? And so there's nothing fancy. It's just a simple string get is what's happening behind the scenes. I'm just getting this response from a cache. So this is why you should have a caching layer in your application. And so now I'm going to sort of introduce to you in terms of what is Redis. And this is a description that's there on the Redis homepage. And the way we sort of understand Redis is an open sourced platform. It's an advanced key value stairs, which is more than just being a cache. So What Redis has is it has these data structures that you can use on the server side, where you can do computations on the server side rather than the client side. So for example, you're building like a Twitter-based application, and you want to show the top 5 tweets. You can store the top 5 tweets as a data structure on the server. So when you make a call to the server, you just say, give me the top 5 tweets, and that's it. You get the result back, and you display it. Where traditionally, in traditional caching solutions, you would make a request to the cache, get the data, and do some client-side filtering on that data itself. So that's the key difference between Redis and any other caching solution. And the way you should think about using Redis is in your application is, again, because Redis has these features around data structures, persistence. It has a pub/sub mechanism for which makes Redis a messaging system. It's something between a traditional database and a cache, because it's still doing this in computations in memory, and then it has a persistence feature where you can optionally persist this data to disk as well, so which makes it closer to a SQL server or a persistent store itself. And so that's sort of the key sort of value add that Redis brings over any other caching solution. And then over persistent stores like SQL or storage, the benefit that Redis adds is the latencies are super low and the response times are like super low, so you can start building like performant applications using Redis. And so the reason sort of we decided to offer Redis in Azure was like when we started looking at the caching world, like about a year and a half back, like we looked at all the caching providers that were out there, like Memcache, we had Fabric, we had Managed Cache as well. And the reason we sort of picked Redis was because Redis, again, had all the feature set. It is widely used in the community. So Twitter uses it, GitHub, WebIO, Pinterest, Snapchat, Stack Overflow. And these folks have built sort of these massively scalable applications which are running every day on Redis. There's a super knowledgeable community out there. Like Redis has been around for the last 6 years. And then folks have learned to use Redis and have customized it quite a lot. There's a rich set of clients, so you can choose whatever platform you want to use. So .NET, there's a client. Node, there's a client. PHP, Python. So you name it, like there's a client for using Redis. And you can use all of these clients with the Azure offering as well. I mean, it's easy to hire for. Like there's Redis knowledge is quite in demand as well. And from a feature perspective, when we're looking at Redis, it had to offer a lot more than just being a straight up cache solution. So it has low latencies, it has high throughput. So if you're doing like gaming scenarios or you're doing real time where you're pumping lots of data, like Redis can handle that load pretty easily. And it's a recommended choice if you're building backplane or you're building scale out solutions for your application. So for example, if you're using SignalR and you want to scale out, like Redis is a recommended backplane for those kinds of applications. It has atomicity built in on these data types, so any increment or decrement, like for example, to numbers are atomic in nature. There are transactions, so you can execute like multiple commands in a batch, and if the batch fails, then everything is rolled back, so it's transaction based. It's got a pub/sub model, which is very similar to a messaging platform, where you can publish a bunch of messages on channels where consumers can subscribe to these channels and get notified. So good examples of where pub/sub is used, it's similar to like queues, basically, or service bus. The difference being that Redis pub/sub is not durable. So there might be some messages that get lost, but if you're building applications where it's fine for these messages to get lost, then it's OK. There's Lua scripting. There is pipelining. You can sort of parallelize how messages are sent between the client and the server. Multiple client libraries. It has this concept of databases. And so what database basically means is within a Redis server, you can have logical separation of data. And so you can say, like, I have a customer app for 5 tenants. Then you can segregate tenant 0 to 5 in different databases. It's a single Redis server, but just a logical separation of data. It's got replication support for syncing, for creating a master-slave scenario where now you have a 2-node cache. So in case the master goes down, then you can fail over to the slave, and then slave can serve all the response. And then when the master comes back up, then it'll get promoted again. There's persistence, and persistence is a scenario where traditionally caches are in-memory solutions where all the data is held in memory. But Redis has an option where you can have two kinds of persistence that you can run your Redis server in. There is a point in time, which is more for, like, I want to take a snapshot of my cache every 30 minutes, every 1 hour. I want to perform some backup operation. So this is more for like disaster recovery. In case my machine goes down and comes back up, how do I restore my data? So that's persistence, point in time. And the second, which is sort of an interesting option, is where you can log every write operation. And what that basically means in a loosely coined word is every write to a cache is persisted to a store. Like it could be a file on disk, or it could be somewhere in storage. So you can think about this being, OK, this Redis is now a persistent store as well. So it offers that. Definitely, if you start using persistence, then it has some performance implications on how much throughput can you get. So it depends on what your use cases are. And the last one is around clustering. And clustering is a feature where, let's say if you want to create a cache size of about 500 gigs, you can do it by one of the two ways. You can create a single node cache, which has 500 gigs of memory. That means you have a single point of failure. Or you can say shard your data on the server side and say, I want to create 10 nodes of 50 gig each, and now have a cluster of these 10 nodes that I can use. So this is clustering on the server side that happens for you. The clients don't have to shard data on the client side. Like the server does it for you. And the reason you want to pick up clustering is because now, let's say if you partition your data into multiple shards, your throughput increases as you add more shards to it. So let's say for a single node 500 gig cache, your throughput is 100,000 ops per second. If you shard it to 10 nodes, your throughput increases in the factor of 10. So now you can start getting like millions of ops per second if that is what you want in your application. So that's where sort of clustering adds value. And clustering was very recently added to the Redis implementation about like a few months back. So a little bit of history lesson is Redis originally is a Linux implementation and is maintained as an open source project. And then there is a Windows port, basically, which ports all these Redis features on Windows, which is what we run on Azure pretty much. So clustering was just added in the Redis Linux implementation. And this is something where it's on a roadmap to offer it in Azure itself. So let's quickly see a demo of Redis in action. I'm sorry, I have to keep switching from extended mode to duplicate mode. OK, so again, I have the same app, and I'm going to search on products. And I'm sort of showing you the data structures that Redis has, which I can use on the server side. And I'll show you the code in a little more detail as well further down in my demos. So effectively, what I've set up in my application is sort of a product catalog where I have a list of products and I have a list of categories. So products can belong to certain categories, and then I can start filtering products based on a category or on the price. I'm going to say, give me the top 10 products in my database. So I'm going to start running these queries, basically. So the first one, let's search on category. And I'm going to do the same operation where I'll search both the cache and the database. Let's see what happened. Hopefully, I didn't lose the internet. OK, let's try again. Oops, that doesn't sound good. All right, let's try something else. Let's see if there's any cache. Oops, all right. Did this break as well? OK, so this is working. If this doesn't work, then I have a local version of this where we can swap to it. OK, so that's not working. Oh, perfect. let me make sure my caches are up. So these two caches are running. Okay. Interesting. Oops. So let me skip this demo, and I'll come back to it later if on my local version if this works. But effectively, what I wanted to show you was, you can start searching on all these categories, and you can start doing all these queries like show me the top 10 products, and the cache results are sort of served to you much faster than accessing the table storage directly, basically, and it's a factor of 100 again. All right. Right. So I'm going to sort of quickly give you an overview of the Azure offering, and then I'm going to show you how do you create caches in Azure and sort of how do you use the different data structures that we have in Redis itself. So from an Azure offering perspective, what we have basically done is we've taken Redis and we are hosting it for you, and it's a managed offering. So that means like we manage the machine where Redis is hosted on, and we do all the management and maintenance operations for you. So you don't have to maintain the Redis server yourself. So it's a PaaS offering. It's a dedicated offering. That means that for each cache that you create, you get a dedicated VM, which is not shared with the other tenants as well. So it's a dedicated cache that you get. There are different cache sizes that you can pick from. So you can go from 256 meg to about 53 gig cache. And the cache is available. The Redis cache is available in all regions. So we are working right now to onboard it to the China cloud and also the US government cloud. It has SSL support, which is only in Azure. So Redis by itself doesn't support SSL. And since we offered it on the public Azure, we basically have a proxy layer that runs in front of the Redis server where we add SSL. And the SSL was added so that any cache operation is sort of not done over clear text, basically. Longer term in our roadmap, like we have features where we allow you to deploy Redis caches inside a virtual network or IP filtering, but that's sort of further down the roadmap. And cache is available in two modes. So there is a basic SKU, and basic SKU is a single node cache only. So you get just one node and basically a Redis server. Now, if the node goes down, then you lose the cache data and the cache availability. So there's no SLA that we provide. There's a standard SKU, which basically there's a two-node cache with the master-slave setup with the replication as well. And so in this case, if the master goes down, then we'll fail over and route all traffic to the slave, and then vice versa. And so in this queue, we have an availability of 3 nines, like 99.9. And this is the availability SLA of how much the cache is available. Some of the other goodness that you get from Azure is this notion of RBAC, which is role-based access control. So that basically means like who can access the cache and perform any management operations. There's provisioning where you can use the Azure preview portal to create the cache, or you can use PowerShell or any of the other commandlets. There is monitoring and diagnostics. So any of the diagnostics data that's in the cache is stored in a storage account that you own. So you can, if you want, access these perf counters outside of the portal as well. You can set up alerts like, if my cache memory grows beyond 80% of my allocated memory, then you can send email or raise some notifications as well. There are ASP.NET session and output cache providers for Redis. So you can use it on either Redis on Azure or Redis on-prem. And there is also a WordPress plugin where if you have WordPress applications and you want to bring in a caching layer, then you can plug in the Azure Redis cache offering as well. So I'm going to sort of show you how you get started with cache in Azure, and then how do you use cache in your applications. So this is the Azure preview portal. So you can say new And then in data and storage, let's reload. All right. Right, so let's say new. Let us load the portal. Okay, so data and storage. And I can select Redis cache. And so the parameters that you need to set for the cache is you need to provide your own cache name. So I can say like, array cache ignite nz1. And you can select the subscription that you want to create the cache in. You can specify what resource group you want to use. And resource group in Azure is basically a logical grouping of resources that you can have. So let's say you can create a resource group which can include a web app, a cache, and a SQL server. And you can deploy all these three resources together and delete all these resources together. And then you can specify your location. Like as a best practice, you want to specify a location which is closer to your web or VM workload. You can optionally enable diagnostics. And diagnostics, when you enable it, you are basically asked to specify a storage account that you own. So all the monitoring, which is the perf counter data, goes to that storage account. And then you can choose what pricing option you want. So basically, do you want a standard or you want a basic SKU? And what's the SKU size that you want in terms of what's the memory of the cache, basically cache data that you want to store. And then you can hit create. So when you create a cache, it takes a few minutes because effectively we are provisioning cloud services for you. And so I'm going to skip that part and I'm going to use the cache that I had already created. And so this is what a cache looks like when you create it in the portal. So you can hit console over here. And I'm just going to show you very basic Redis operation. So you can set a key using the set command, like set A1 to be B123. And then it's going to set the value. And then you can do a get command, which is get A1. And it's going to return the value of this key. So this is a very simple like CLI. This is basically in the portal we are running this exe called Redis CLI, which is a Redis command line interface that you can use to interact with Redis. And so this sort of allows you to easily get started with Redis itself. And so now let's use this cache in our application. And what I have over here is I have a simple console exe. And I have downloaded these client called Stack Exchange Redis. So Stack Exchange Redis is a free client for C# like .NET apps. But if you go to redis.io/clients, these are all the clients that you can use to talk to Redis. And you can use the same for Azure as well. Yes? The Stack Exchange Redis? So there are two popular ones. There is Stack Exchange Redis, and then there is Service Stack. So Service Stack is a paid client, and Stack Exchange is free. So most people tend to start with Stack Exchange Redis, and then they use Service Stack if there's a need for it. But yeah, as you can see, like they've both been marked with the star on Redis.io. So both are recommended, basically. Right, and so let's see a simple program to connect to cache and get the results. And so what I have over here is a simple pattern on how do you create a connection to a cache and how do you set a value and get a value. So I have this call of connection.getDatabase, which is I'm using Stack Exchange Redis, and I'm creating a lazy connection. So basically, I'm creating a singleton pattern. So I'm going to use the single instance of the multiplexer across all my for this entire app. And the reason we recommend this is because what we saw for a period of time that if you were using multiple multiplexers in your apps, over a period of time, there were bugs in Stack Exchange where they used to leak connections. And suddenly, after 3 months, you'll have about 10,000 clients connecting to the same cache even if you had like only 5 instances of the multiplexer. So this is the data that we saw from our own logs, where then we reached out to Stack Exchange, like we fixed bugs, and as a best practice, all our samples sort of guide you towards this pattern. And to connect to the cache, I basically specify my cache name, which I can get from the portal. This is my so this is my cache name, and then by default SSL is true, and the non-SSL port is disabled. So that's a default setting, and you only should enable the non-SSL port if you're running any of the Redis tools like Redis Benchmark or Redis CLI, because those require the non-SSL port. And then I have to specify the password, which is something I can get from my access keys. And so you have same like a primary, secondary access key. You can keep rotating these keys as per your sort of requirements in your app. And then I'm using very simple APIs of string get. It tries to get a value from the cache. In my case, if the value doesn't exist, then I get from my persistent store, and then I can store this value in the cache as well. And then I sort of print out this value. So if I just run this app, the reason it's taking this time is because my cache is created in the north central US, where interesting. Timeout exception. Okay, that doesn't sound good. Let's try again. Okay, so that worked. So the reason I got a timeout exception was because my cache is provisioned in US and my client is in New Zealand. And so the network hop it's doing is quite large. And that's the reason I wanted to sort of emphasize is your client and cache should be in the same region itself. So this was a simple hello world. Let me start running you through the different data structures that Redis has, and like how can you benefit from all those data structures itself. So let's look at Redis strings. So I showed you how you can sort of do a simple string get set operation. Now, if you wanted to store objects in your cache, you have to serialize and deserialize objects. And I'm using JSON.NET. You can use whatever. So this is how you can serialize and deserialize an object and store it in the cache. This is how you can set key expirations. So let's say some keys will expire after some time frame, or you have your own logic. So this is how key expiration works. So I can run this. Oops. I should probably increase my timeout settings. All right, let's not do that. So let's look at general concepts. Okay, so what this is covering is so how do you do pipelining, where you can now use the async APIs and you can fire off 2 commands and you can execute them in parallel. This example shows you the atomicity feature, where you can, if you want to increment a value, you have special APIs called string increment, which is going to increment that value in an atomic manner. There is a string get set, which gets the value and then sets the value as 2 operations. And so you can see the result that once you do a get set, if you output the result, it'll be the get call, and then if you set the value, then you can see the result of that. You can also run this notion of mget and mset. And so mget and mset is basically multiple gets or multiple sets. So within a single request to the Redis server, you can run multiple gets or you can run multiple sets together. So effectively, the command to do it is like string set, and you pass in a key value pair list. There's also transactions. So transactions allows you to execute multiple commands together, and then if the entire transaction succeeds, then you can see the results. So in this, I'm creating this transaction, and I'm doing a string increment on as one operation, and then string decrement as another operation, and then I'm executing this transaction. And then I can output the result of the transaction. If it succeeded, this would be, by default, when you set a value, it's a 0. So the result of the increment will be 1, and the result of the decrement would be sort of -1. And so this is how you can start doing transactions. Let me see if this would succeed. Yep. So again, so the transactions, the result of the increment was 1, the result of the decrement was 1, but you can sort of effectively start batching operations together. Tags. So this is interesting now. So tags is, it uses a data structure called sets. And basically, you can think about tags in the following scenario. So let's say you have a news application where you have a bunch of news articles. And news articles can belong to different categories. And now you want to start doing these searches on, give me all the news articles that belong to a category called C#. Give me all news articles that belong to C# and VB. Find me all the tags that these 5 news articles belong to. So you can start doing all these sort of richer tagging queries as well. And what the syntax for that is basically, here's how you can get these results. So show the tags for blog post 1. So you can, this is pretty much how you start defining your keys. So blogs::post::1 will give you the blog post 1 and give you all tags for that blog post. Let's say you wanted to show all the tags which are common in post 1 and 2. Then you can do like an intersect operation as well. So you can do intersect, you can do union, and it will give you the result as well. You want to show all the IDs which are tagged with IoT. So you can use this pattern to get the result as well. So that's basically tagging. So in my earlier example, when I was trying to look up products by category, so it was using tags basically. And tags are a super quick way of accessing this kind of data. And I'm not going to attempt to run it because it's going to time out. So this was tags. And then there's a concept of Redis lists. And so Redis lists are effectively, in a loosely sense word, there are basically linked lists. So where adding of a new node is like super fast because you're adding it towards the end. And then these data structures are useful if you're doing operations around, okay, give me the last 5 tweets. And then you can be smart enough to sort of structure your data so that you can start doing these operations where, let's say you wanted to access the last 5 posts that were read, then you can do cache.list_range from 0 to 5. But let's say if you wanted to only show the last 5 at any given point in time, then you can always do a list trim of the 5 or the 6 last items that you want to read, and then you can show the result over here. So that's how you can use cache lists. And for the set operation, you're basically doing a list, either a left push or a right push, depending on if you show the last 5 or the most recent. So which direction do you want to go? So that's how you can sort of use this data structure. Then there are sorted lists. And so what sorted lists allow you to do is you can assign a score to your entries. So let's say you want to say, give me the top 5 gamers in my application, or give me the top 5 products that sold in the last 5 days. So you can assign some sort of score to the data that you store in the cache. And so in my application, what I've done is basically I have added a rating for my blog posts And I can now start to do queries around, okay, give me the top 5 blog posts, or give me the top 5 blog posts which are sorted in ascending or descending order, or give me the blog posts which have a score between 3 to 5. So give me the blog posts that are greater than 3 and less than 5. So this is how you can start using sorted sets as well in your application. So then there is connection options, and we can, which is basically now specifying like different settings that you can use when you connect to the cache. So like if you want to use the SSL connection option, or abort on connect equals false, connect retry, or connect timeout. So you can start specifying all these options based on your load. And I'll sort of cover these more towards the end when I talk about the FAQ on sort of why these matter. Then there is a notion of key space notification, and key space notification is a scenario where, so let's say you want to be notified in your app each time a key is added, deleted, modified, or there's some operation that's happening in the cache. And key space notification is basically a scenario over there. And key space notification builds upon the pub/sub feature of Redis, where you can be notified of these events being raised. So I'm just going to launch this application. And then I'm going to go back to my cache demo 1. And I'm going to set a key. And then this notification was raised basically in my application. So in my code, what I had was, I'm looping around and I'm subscribing to this channel key space for database 0, and I'm listening. The stars symbolize that I'm listening for all notifications in this Redis cache basically. So any time a set get happens for any of the keys, I'll get notified. And so you can sort of fine tune this logic to be based on the keys that you're interested in, and then do some operation around it basically. You can also use Redis in ASP.NET. And so in this example, what I have here is it's a web forms app which uses session and output caching. And I have installed these two packages, Microsoft Web.Redis output cache provider and session state provider. And this is basically providers for Redis. And in my web config, you would see that now I've switched the caching, the output cache provider to be Redis, and the session provider to be Redis as well. And I'm specifying their connection string as Redis connection, which is defined as my app setting. So the same like cache demo 1. And then in my application here, I'm basically storing some data in session, which is the current date time. And in my ASPX page, I've enabled output caching. So if I just launch this application, and just refresh, so you'll see this date time will be constant basically each time I refresh the page. And so because this is now coming from output cache. So this is how easily you can sort of plug in ASP.NET session and output cache providers to Redis as well. You can also use Redis pub/sub. So here is what I have as an application. And if you guys want to play, if you have any devices, phones, or you can browse to this URL. Any volunteers who want to do it? Come on. All right, I'll give you 10 seconds to do it. So Pranav, Redis, signalar.azurewebsites.net. And we'll burst some fireworks over here. OK. So let's start bursting some fireworks. Let me open another browser. Let's use this URL here. Oh, wow, somebody's playing. Nice. So I can keep bursting these fireworks. Behind the scenes is basically it's using a SignalR hub. And oh, wow, awesome. And I have plugged in Redis as a backplane where I can now use Redis to scale out all these like millions of messages or fireworks that are coming in this application. All right, you guys happy? Should we stop? Oh, that's a cool picture. All right. So, I mean, the code for it is pretty simple. Like, I have this web application which is using SignalR, and then in my startup, I have plugged in a Redis backplane where I've specified my cache URL and my cache password, which is basically the same cache password I was using for my demos. And then behind the scenes, sort of SignalR takes care of scaling out all these messages using the Redis backplane. And so there's where you can use the PubSub model of Redis to start scaling out. I'm sorry, there was a question?
No, sorry, something happened on my phone.
Oh, okay. I was wondering, I didn't add any like sound to my demos. Like, all right. So I wanted to show you, like, you can use .NET, but you can also use other clients to talk to Redis as well. And in this example, I have a Node application which has this Node file. I'm using a Redis client called Redis, which is listed on redis.io. Again, there are different clients that you can use. And I'm simply connecting to my cache endpoint. And in this case, basically, if you notice that I'm using the non-SSL connection, because not all clients support SSL, since SSL is not native to Redis, only a few of them do. So I have to enable the non-SSL support. I'm doing a set call where I'm setting this key to value bar 1234. And then I'm getting this value here, and I'm just outputting the result. So it's a simple get set call. And I can drop down and I can say node myapp.js, which is basically going to set the value, and it'll sort of get this value and it'll output it basically. So the point being that you can sort of use any client or any platform that you have and just connect to Redis. Like Redis is not tied to Windows per se. Like you can use anything. All right. Any questions? No. All right. Let's look at our FAQs then. Okay. So, I sort of talked about in the beginning a little bit on there were different caching solutions, sort of which one should you pick. We recommend sort of Redis for any new apps that going forward. Here's a link that talks about sort of why. But the interesting one that I wanted to talk to you about was how do you pick the right cache queue? And I just want to make sure that this message sort of resonates well. Is you sort of should think about the following factors when picking a cache. You always think about how much data do I want to store in the cache, which is a given on what the cache size should be. But what's not very apparent is, what kind of workload are you running and how much network bandwidth do you need or how much CPU power do you need when you run Redis. So if you're running a very high throughput workload, then you want to pick up a SKU which sort of gives you that network bandwidth as well. And so if you pick one of the lower SKUs like C0 and C1, I mean, the network bandwidth over there is pretty low. And as you scale up to higher SKUs, you'll get more bandwidth. And this is simply because of the infrastructure that we have. On certain hardware that we deploy, you get lower bandwidth. And on a different hardware that you deploy, which only comes when you have a higher sized VM, you get better bandwidth. So you kind of have to factor in both of them together when you pick up the right cache SKU. And if you don't do that, and sort of the issues that you start running into is, let's say you pick a C0 cache, which is 250 megs. I think the bandwidth on that is pretty low. It's about 5 Mbps. And let's say the workloads that you can run are about 10,000 ops per second. But you want to run a workload which has 50,000 ops per second. And if you start running that, then you will start to get throttled on the network, and you'll start to see a lot of timeout exceptions happening in your client, and you'll sort of wonder as to why that's happening. So that's why network bandwidth is a key option as well when you decide what cache SKU you want to pick. And the last one is, the cache and client have to be the same region. Like, I just cannot emphasize how often we've seen folks who have deployed their solutions where this is not the case, and they've come back to us and say the latencies are like, greater than a second. And the most common cause for that is that both the client and the cache are sort of not in the same region. This slide sort of talks to you about some of the performance characteristics that we have seen in Azure. There is, again, no guarantees on these numbers. Like, these are numbers that we've sort of achieved by our own internal testing. And again, performance always depends on what your workloads are. So we always recommend to measure it based on your workload. But effectively, what we see is, what we did was we set up a Redis cache server in Azure, and we set up a corresponding VM in Azure, both in the same region. And then we were using this tool called Redis Benchmark, which is a benchmarking tool in the Redis offering. And you can use to sort of measure latencies and throughput using this tool. And so the numbers that we get, and over here is basically around, let's say you were doing a get set calls of a payload which was about 1 kilobyte each. In terms of ops per second, you'll see that on a C6 cache, you can at least do a 150,000 ops per second, which is amazingly high. But on a C0 cache, you can only do a sort of 600 ops per second. And this is simply a characteristics of the underlying hardware. And so these are the numbers that you should be aware of while picking up the cache. These are not guaranteed. It always depends on what benchmark you want to run in terms of the load that you want to run in your application, but it should form sort of as a rough guideline and as to what can you expect. In terms of scaling, there are two modes that you can scale. You can scale up the cache. So you can pick a C0 and go to a C6. You can also scale out, which is a feature that we have on our roadmap, which is basically clustering, where you can add, or we can add more number of shards, or you can reduce the number of shards that you have in your cache application. There is monitoring that you should always have in the portal, where you can measure your perf counters. There is an interesting characteristics around sort of memory management. So effectively, what happens in Redis is there are two kinds of perf counters for memory. There's used memory and there's used memory RSS. Used memory RSS is effectively how much memory is used by the cache data, and then the metadata around, like how much keys are being stored. And used memory RSS might be higher than used memory, but if it grows higher beyond a point, then effectively what has happened is Redis has allocated more memory than the OS has, and you'll start to see a lot of page faults happening on the server side. And if you start to see a lot of these situations where you're monitoring your caches and you're constantly seeing this number go up, then you're running a workload which is not suited for this particular cache size, and you should scale up to a bigger cache size, basically. From a client configuration perspective, what I showed you was basically make sure that you have the latest version of Stack Exchange so that it has all the bug fixes that we keep seeing. You should use a single instance so that it's shared across your app and you don't have any leaky connections. Make sure abort on connect is set to false. This is a setting which allows Redis, Stack Exchange Redis to reconnect if a connection was aborted. So the default is sort of true. And then you should optimize your workload for the connect, retry, and connection timeout. So this is effectively signifying how often should I retry, and what's the time limit when I should time out before I wait for a response from the cache. And it's very subjective to what load you're running in. So for example, as a best practice, we always say that Redis is best optimized for keys, for smaller keys, basically. And the reason is because Redis is a single-threaded server, and it's a queue-based system where commands come and they're queued up, and Redis is processing one by one. So if there is a long-running command that comes, or if it's performing operations on large keys, the other commands in the pipeline will get blocked until all of them are processed. And so that means that you'll now start to see timeout in your client apps as well. So you need to fine-tune these settings based on your workloads are. As a best practice, as long as you keep your workload consistent and have like small keys, you'll be fine. A strategy that you can use is if you have workloads of two kinds with small keys and large keys, you can have two multiplexers. One deals with small keys and one deals with large keys, and both of them can have different timeout values. So you can be like strategic about it if that's the kind of workloads that you want to run with the Redis server as well. And then I'm going to sort of show you. I'm going to skip a few slides, and I'm going to talk to you about roadmap. Right. So everything I've shown you so far is available in Azure today. This slide talks to you about what you can expect to come in the coming months from the Redis cache service. Support for scale up and down is already out in preview. We're just about to release support from scaling from basic to standard. You can configure Redis for key space notifications. So that's available today. You will be able to enable persistence, and you can be able to run persistence in both modes, like persist every write, or persist as a snapshot model where you can optionally persist data at some point in time. Region availability is going to happen. Redis cache is available today in all public Azures. Government cloud is following. We are going to offer clustering as well, so you can create clusters of up to like 500 gigs, and then it'll just increase. There is support for virtual networks as well. So in Azure, you can create a virtual network, which allows you to further sort of lock down who has access to the network. You can define your own NSGs and have more advanced scenarios over this. So this will allow you to deploy a Redis cache along with your web tier workload inside a VNet as well. And then you can lock down your cache as well inside a virtual network. And then there's the geo-replication. So geo-replication is a feature around, there are two ways to treat it, basically. There's a scenario where what happens if a region goes down? In that case, how do I handle the disaster recovery scenario for cache? So today there is none. And what this will allow you to do is, so let's say if region A goes down, you can have a geo-replicated cache in a different region, and then you can fail over to that region if the region goes down. So that's a disaster recovery scenario that we are sort of looking to enable based on the feedback that we've heard. And then these are some resources that you can look at. This is the pricing model. There's a documentation of all the features that I've showed you of Redis. There's a user voice that we track active feedback on the features that customers want. There are some blog post articles on how do I specify my retry logic. There's a pattern and practices sort of link to it. There is timeout exceptions, the link to the WordPress integration with cache. And then I just wanted to sort of thank you for coming to this talk. Please do fill the evals. It helps us to structure these talks better. And if you have any questions, I'm going to hang around here for a few more minutes. But thank you for coming to this talk.